What if I told you that a $3,000 3D printer could replace a $50,000 injection molding run? Or that aerospace companies are using $100,000 printers to replace million-dollar traditional manufacturing setups? The world of professional 3D printing is transforming manufacturing as we know it. And today, we are breaking down the three main technologies making it happen. The companies are cutting production times from months to days and prototype costs from thousands to hundreds. But here's the catch. Choosing the wrong technology can be an expensive mistake. Let us show you exactly how to pick the right one for your business. While we're focusing on these three technologies today, it's worth noting that the 3D printing world is vast. From metal printing to ceramic solutions, there might be other technologies that better suit your specific needs. We'll dive deep into those in future videos, but for now, let's understand the most widely adopted solutions in the industry. Let's break down our main players: FDM, or fused deposition modeling, laying down molten layers of plastic; SLA, or stereolithography, lasers turning liquid into solid; and SLS, or selective laser sintering, basically a laser drawing in powder. First up is FDM, or fused deposition modeling. Don't let the technical name throw you off. It's a surprisingly straightforward technology that can handle serious business applications. Here's how it works. Imagine a precision robotic system with a hot glue gun attached to it, laying down molten material exactly where it needs to go. Modern FDM printers can work with everything from corn-derived basic plastics like PLA to carbon fiber PEEK composites for aerospace-grade performance, giving you serious versatility. Where does FDM shine? It's perfect for quick-turn prototypes that can handle real testing, custom manufacturing tools and fixtures, proof-of-concept models that actually work, small production runs, or even manufacturing thousands of units of parts. Let's talk numbers. Professional FDM systems range from $400 to $50,000. Engineering-grade materials run $50 to $150 per kilogram, but the real value is in the quick turnaround and minimal post-processing. You can literally start printing within hours of setup and just take the part off the build plate when it's finished. Next up, SLA. SLA technology harnesses the power of light, using a low-power UV laser to transform liquid resin into solid parts with incredible detail. The result? Parts so smooth and precise they can rival injection molding quality. The applications are vast. Medical prototypes requiring perfect detail, dental aligners and surgical guides, high-end product prototypes, precision engineering parts, end-use consumer products, jewelry design and casting. And that's just scratching the surface. But here's what many don't tell you up front. SLA requires a serious production setup. You'll need a dedicated space with proper ventilation. Resin has a strong odor and requires careful handling. The post-processing workflow isn't optional. Parts need washing in isopropyl alcohol baths, UV post-curing, and proper safety equipment including nitrile gloves and respirators when handling uncured resin. You're not just buying a printer, you're setting up a mini production facility. Professional SLA printers start at $500 and can go up to $100,000, with materials ranging from $50 to $400 per liter. Now, let's clear up something that often confuses people. SLA versus MSLA. Traditional SLA uses a laser point, meticulously tracing each layer like a precise pen drawing. MSLA, masked stereolithography, takes a different approach, using an LED array and LCD mask to cure entire layers at once. Think of it as a digital stamping process. Here's the interesting part. While MSLA was once considered the budget option, recent advances in screen technology and materials have changed the game. Modern MSLA printers can match or exceed traditional SLA in most applications, while being both faster and more affordable. The traditional wisdom was that SLA won for fine detail, but today's high-resolution MSLA screens have largely closed that gap. MSLA now dominates the market with faster print speeds, lower costs, excellent detail, and great scalability for batch production. Your choice between the two often comes down to build volume needs and specific application requirements rather than quality concerns. Both technologies can deliver professional-grade results, but MSLA typically offers better value for most business cases. Do you want to gain a deeper understanding into additive technologies? Head over to our profile and sign up for our newsletter. Finally, let's talk about SLS, selective laser sintering. This is where we enter full production territory. SLS is like having a mini factory in a box. It uses powerful lasers to fuse powder materials into solid parts. The cool part? The surrounding powder acts as support, so you can create literally any shape you can imagine. While SLS works with a more limited range of materials compared to FDM or SLA, it excels at producing durable, functional parts. The most common materials are various grades of nylon, glass fiber-filled nylon for added rigidity, polypropylene, and flexible TPU for specific applications. One limitation to keep in mind: color options are restricted. You're typically looking at white or gray parts off the printer. While you can dye or paint them later, that's adding another step to your process. And regarding post-processing, it's no joke. You'll need media blasting equipment to clean excess powder, proper PPE including respirators and protective suits, dedicated powder handling and recycling stations, and an industrial vacuum systems for cleanup. Let's talk numbers. Entry-level SLS systems start at around $15,000, with industrial systems going well above $100,000. Materials run between $100 to $500 per kilogram of powder. Here's the silver lining. A significant portion of unused powder can be recycled between prints, which helps offset the material costs. When you combine this with the ability to nest parts throughout the entire build volume, SLS can be surprisingly cost-effective for the right applications. Just remember to factor in the post-processing equipment and safety infrastructure into your initial investment. Let's break it down in business terms. FDM, the most budget-friendly professional option, quick to implement, tons of material options, but is limited in fine detail reproduction and part strength. SLA offers incredible detail, capable of producing medical-grade parts. Prints have a beautiful finish, and you have a wide variety of material options. Unfortunately, it has a more complex workflow with more setup time and messy post-processing. SLS, production-ready, offers ultimate design freedom, is efficient for large batches, and produces very strong parts. But it's a significant upfront investment. There are many considerations when choosing the right technology and printer for your application, and choosing the wrong one can hinder your work. So, how do you choose? Some things to consider are what kind of volume you're planning on producing, how complex your parts are, who will need to operate the machine, any industry certifications you need, the amount of space you can allocate, and your budget. There you have it, the real deal on professional 3D printing technologies. Which of these technologies interests you most? Drop a comment below, FDM, SLA, or SLS, and we'll create an in-depth technical guide for the most requested one. Thanks for watching.